how Web3 apps are going seamless and secure. So I'm going to start out with a little bit of a history lesson. Okay, so let's talk about security. So one of the things that we've learned at MetaMask as we've been building out security tooling and safety features for users is that the internet as we know it is actually not secure at all. Okay, so users are browsing different websites, they have their browsers, they have their apps that they use to access the internet, and there's actually very little protecting them on the internet. Like the internet has just not caught up. The web standards have not caught up with the risks of using the internet. And one really good example of this is HTTPS, okay? So HTTPS is a protocol that just ensures that when you're connecting to a website, your communication back and forth with that website is encrypted, right? So nobody can try to read those messages going back and forth, even if they have access to those messages. And initially, when this feature became available, one thing that browsers did was they put a little padlock icon, right? When you would connect to a website, you would see a little icon that would tell you, oh, your communication with this website is secure. And that actually was not great for users because what it told them, the impression that they got was, oh, this website is safe to use, right? That little padlock icon means that everything's good to go with this website. And that's not actually what it meant, right? So users didn't actually have any way of knowing, is this website compromised? Am I connecting to a website that's pretending to be gmail.com, but it's actually not gmail.com, and it's just spoofing it? Right? Because any website could have an encryption certificate and basically show up as being safe to use. So in reality, when you connected to the website, trusting that website was really just a matter of blind faith. You actually have no way to verify that the content of that website is what the developer intended to give you, right? It could be completely hacked. There could be a malicious package somewhere in the supply chain that's compromised the website. You might see a weird pop-up. Maybe you click a couple things and suddenly you have an extra bar on your browser, or maybe your cursor changes into a little wand and you're like, what just happened, right? So Google actually had to retire the padlock icon in Chrome and stop showing that because they made a mistake, right? They were giving users the impression that this meant that the site was secure, and it's not. So when we added financial rails to the internet, it became really obvious what the shortcomings were in terms of security. Because now that you make it easy for funds to transfer and for users to have funds and maybe one-click send, then you start seeing all the ways that this can be abused and all the ways that the internet just doesn't protect users. So I don't know if any of you remember this what's in this screenshot. Does anyone know what that is? Any old heads in here, maybe? This is Mist browser. This is like pre-MetaMask. This was like back when they were like, hey, let's make our own browser for Ethereum, and we're gonna like onboard people to the decentralized web through a totally new browser that has all that wallet functionality built in. And for a brief time in these early days, it was just assumed that users could browse websites and that those websites would be honest and trustworthy and wouldn't try to do anything malicious. And then very quickly we wisened up and realized that's not the case, right? To give you an example, MetaMask used to have by default enabled this signing method called ETH_sign, ETH_sign. Now, if you look in our documentation at ETH_sign, there's a bunch of red boxes that tell you to be careful about it. Because ETH_sign is basically just, you could sign a message that does anything. The message could just be like, give me authorization to transfer everything out of your account, right? And the earliest drainers were basically just tricking people into doing malicious ETH signs. And then we realized that, okay, we can't trust developers, to be honest. Unfortunately, a handful of malicious developers make the ecosystem bad for everybody. So we're going to have to put a lot more controls. We're going to have messages that very clearly specify what the signing method is doing, and then build a bunch of security tooling around it to prevent those sorts of things. So we've essentially been fixing the security problem in the web in our ecosystem, right? And what we've been doing is really pioneering security for the web in general, because we're having to solve problems that nobody really had the financial incentive to solve before, but now these things need to be solved, right? In order for users to be able to get the benefits of cryptocurrencies, they need to be able to browse the web safely. So one of the core principles behind the design of MetaMask is that users are in control of their interactions with sites, and we call these consentful interactions. When I was making this slide, the little grammar checker said that the correct word is consensual interactions, but that word felt a little weird to me, so I just went with consentful. So if like the dictionaries could just add consentful as a word, I would really like that. I'm way more comfortable with that term. But essentially, the way this works is that everything that a site wants to do with your wallet, it has to first request permissions. And the initial permission is just give me access to the account that I'm then going to make requests for, right? And so we've designed our interfaces in such a way that you see which website is making this request and which accounts does it want to use. And we're actually moving towards even more clarity about what the website wants to do with those requests. So what we're moving towards is even for a website to say, okay, these are the chains that I want to use. These are the methods that I'm going to use on those chains. And we can really give users a very clear understanding of here's what I'm getting myself into with this website. And so the consent flow is populated with all of this information, and it keeps users in control of what it is that they're giving a website access to do, right? So they have a bit of separation with the developer of like, okay, I'm going to slowly build trust with you. It's not a default trust situation. And so one example of this that's even really interesting, so how many of you are familiar with sign-in with Ethereum? Sign in with Ethereum, yeah, okay. It's really cool. You can basically do an authorization flow with an Ethereum account. And something that I think a lot of developers are not aware of, because I still see developers getting hung up on this, is you can actually bind a sign in with Ethereum request to a domain, right? So you can even say like, this request is for this domain. Maybe the domain is like safari.io or chomp.xyz or something like that, right? And so you can ensure that if someone tries to mimic that request, because they're not able to bind it to your domain, then the user will actually get a warning. So this is what the request will look like if you try to make a sign-in with Ethereum request with the wrong domain bound. And it'll actually show you the site you're attempting to sign into doesn't match the domain that requested it, so you should proceed with caution, because it's trying to get some authorization for some other website that might be a phishing website, or maybe trying to mimic or pretend to be the website that you thought you were interacting with. And I'm going to give you an idea of how you can go even further to prevent what we call site jacking, which is essentially how a malicious website pretends to be one that people trust, right? Maybe a fake Uniswap or a fake OpenSea. So one of the things that we built at MetaMask, it was actually incubated, founded by one of the MetaMask founders, who saw what was happening with websites and all of just how much they were lacking in terms of security, and he went and invented this thing called LavaMoat. And so LavaMoat is a set of tools for securing your JavaScript projects against supply chain attacks, and it ensures that your website cannot be hijacked by malicious packages. So what this is that nowadays when people make websites, they use lots of JavaScript packages that give them like a starting point, provide a bunch of functionality that they will build on top of. But you don't know if one of those packages might have something malicious, right? That adds something into the set of dependencies that actually can try to manipulate users on your website. So what LavaMoat, one of the things that it does is completely lock that down and prevent those packages from having any influence on the final website that you're deploying. And it also allows you to deploy a website with the packages that you actually wanted to use, right? So it's a bunch of tools that allow you to lock down your website. I will not try to get too much into the technicals. I'm the wrong person to talk about it. But if you check it out on GitHub, it's github/LavaMoat, and you can learn more about it. But on top of that, the next step, and this is something that is still sort of in the very fledgling stages, and I think developers need to start working on building this out as something that we can all take advantage of. It's called content addressing. And so we actually have the infrastructure for this today, and if you talk to the teams at like Ceramic or Protocol Labs, I'm sure they'd love to talk to you about this. So you can even go one step further and say, okay, here's the set of code that I'm deploying for my website, and then here's a verifiable hash based on that set of code, and then I can go attest, like maybe I have my metamask.eth identity, and I can say, I have just deployed this website with this verifiable hash, okay, and make an attestation, right, with an attestation service like Verax or something, or Ethereum attestation service. And then users can know, okay, this website that I'm currently loading into my browser matches what someone from MetaMask says they deployed, right? And then if you can even build the tooling to say, okay, if this website that you're loading doesn't match that hash, then maybe that's not the website you thought you meant to load, right? Maybe that's not actually from Team MetaMask. Maybe their website is compromised, or you're going to another domain that's pretending to be MetaMask, right? And so what I'm talking about here is something that the tooling is available, and I would invite developers to start building with it, because this is something that we need to take advantage of as well, right? Especially for something like Uniswap, where like the Uniswap app is like a big honeypot that people want to try to attack and mimic, right? If every version of the Uniswap app was published with a content address that's verifiable, then people would know, okay, Team Uniswap says that this website is the correct website that I'm loading, right? And if they go to a website that doesn't match it, then they'll know just even based on the content, oh, this is not Uniswap, I need to get out of here quickly. And I say this partly because we actually use a very similar mechanism with snaps. So how many of you are familiar with MetaMask snaps? We've talked about it a little bit today. Okay, so one of the things that we do with snaps is when the developer is building using our tooling, it generates a verifiable checksum based on all of the content of the code, all the files that are in there. And that checksum is deterministic, and then MetaMask uses that checksum when you're installing the snap into MetaMask to make sure that it matches what's on our allow list. So this is actually really powerful, because people always ask me, okay, well, like, what if you install a malicious snap? And it's like, you actually can't install a snap that hasn't been vetted and verified in our allow list. Like, that's actually not possible. Even if the developer makes changes or someone makes malicious changes to the code, the checksum will not match. So each version that has that verifiable checksum has actually been vetted by us, and that code can't change. And so this is one mechanism that we use to ensure that what we're doing here is really safe for users. And it's part of, like, I always tell people, what we build with MetaMask Snaps is primarily a security product, right? There's all these security controls in it that allow us to make a trustworthy and safe to use application platform. So the reason I talk about security initially, I know I talked about how we can make Web3 apps seamless and secure. I started with security because you first have to ensure a certain level of trust and security with users to then go seamless, right? Because when we start talking about use cases like embedded wallets and seamless onboarding and stuff like that, we're actually abstracting away all the underlying functionality, right, that can potentially put users at risk. So users need to know that, hey, if I'm going to onboard to a wallet or delegate, maybe this dApp can make transactions without confirmations for the next hour or so, they need some assurances, right? They need to know that, hey, can I trust this dApp? Am I comfortable allowing this dApp to maybe make 0 confirmation transactions for the next hour for some kind of game experience or something like that? Or am I comfortable delegating money to this dApp to do like an offer on an NFT that could be redeemed later on, right? So once we solve security, then we can build really cool, seamless experiences. And I'm going to show you one example. So one of the things that we did with Snaps is we've been building embedded dApp interfaces with Snaps where you can actually build applications that run inside of MetaMask. So you're running on top of and within all of the security assurances of the Snaps platform and delivering these interfaces for your users. So I'm going to show you an example of how this works with the Linea Voyager Snap, which we built within Consensus. And this is how it actually shows you how you can verify the package that you're installing, the information about the developer, all the different permissions that it uses. Then you have it installed. And then you can actually go into the MetaMask menu, right, to open the snap, and then interact with the interface that the snap presents. Okay, so you open the Linea Voyager snap, and now you have this embedded dApp interface, which includes a lot of different information, like the different activations that are currently available. And what we're working on in the future is actually more interactive features. So you can do all of the things you would do with the Linea Voyage from within that snap itself in this embedded UI. Another example, and I want to shout out XMTP here. So XMTP built this really cool snap that's called Sign In with XMTP. And so some of the APIs in the Snaps platform, they include local secure data storage and also custom methods. So you can make a snap that has its own methods for communicating with dApps. And so what they're actually doing is they're storing the keys in MetaMask, right, for the XMTP user account, and then they can facilitate then seamless sign-in. When you go to an XMTP-enabled dApp, it's able to use that snap to say, oh, hey, yeah, this is this XMTP user. I can make a really seamless login for you. And another really cool thing about what Snaps enables you to do is you could make a snap that just privileges specific dApps that it communicates with, right? So maybe you have an application, and then you have multiple dApps that you've deployed, but you need to limit functionality to only those dApps that come from you, right? The dApps that you've actually deployed deployed, you can make a snap that just communicates with those dApps. So you can lock it down however you want. And so then users trust like, oh, I'm installing this snap, but it's only going to do authorization and login with the dApps that the developers vetted. Right? So it gives a much more trustworthy experience. And it's interesting because, we assume that, oh, all these users are anonymous and they don't trust us, they don't trust developers, but really they're looking to developers. They're looking to you to say, okay, here's the experiences that I built for you, and I can lock that down and make that available to you in a way that's secure, and you can explore these websites and trust that this is from me, right? So you're building a trust relationship with users, and you're able to do that in ways that are really seamless. And so that's what I wanted to present to you today. And then I will just close with a little bit of a preview. So I've been talking about interactive UI, and I've been looking for a good example that I could show you. So I was at 8cc yesterday, and they had this section, they were like, oh, the retro area, and it was like Tetris and Minesweeper and Street Fighter and stuff. And I went there thinking that I was gonna play the games, but apparently it was just the names of the rooms. So I was like really disappointed, right? Like not happy with ECC for that. But I saw Minesweeper, and I was like, oh, I know Minesweeper, that's a fun game. So I actually ported Minesweeper into MetaMask as a snap, and I'm gonna show you how it looks, and you'll see the interactive UI that we built, and hopefully this inspires you to make some applications yourself. Yeah, so this is Minesweeper inside of MetaMask. It's a fully interactive UI, embedded dApp experience, no reloads or anything like that. It's not an iframe. It's built using our new UI library. It's fully interactive. You can actually flag spaces, but I didn't do that in this demo. And you can see how I'm going around here, and then, oh, I lost. So yeah, that's Minesweeper inside of MetaMask. Hopefully you'll build some cool applications for us, with us. So yeah, that's the end of my presentation. Definitely ask me any questions that you have. I think we have time for some questions, maybe? Any questions from the audience? You can ask me about anything related to MetaMask. One back there? Okay, cool.
Hello. Can you hear me?
Yes.
What are some of the snaps or category snaps you would like to see built?
So I definitely want to see some games built. I'm actually thinking of running a hackathon in a month or two to have people build games with it. But another thing that I want to see people build, and it's similar to the Linea Voyager example that I showed, we actually built that. It was myself and a couple engineers that built that within Consensus. So essentially, let's say you have a dApp, and you have maybe quests or certain experiences, right, that users can do, or maybe they have communication between users, and you probably want to increase engagement, right? You want users to be engaged with your dApp, come back to it when there's something to do. Maybe they have another turn in a game, or maybe they have an offer on their NFT, whatever it is. So you can build a snap that people can install into MetaMask, and it can actually do notifications, right? And you can even show them like, oh, you have 2 pending offers, or you just got a message from someone, or it's your turn in a game of chess or something like that. So those types of applications that basically treat MetaMask as the hub for the user of everything that they're doing, and then build in those connected experiences where they can know when there's something for them to go and do on your dApp. Those are the kind of experiences that I would like to see people build. Any other questions? All right, thank you, everyone. I'm going to hand it off to Francesco.
Thank you so much, Christian. So how many of you guys know not just what are snaps, but will you use snaps next one if you didn't know it? Yeah? Okay, sounds good. Cool, let's give us some closing words, right? So we mentioned why we're here, and this will be super quick. And I think we try to really jump in different topics on different verticals, not just around what's surrounding MetaMask, but also on different ecosystem topics, right? And we want to empower different players in the ecosystem, come and support and present what's happening in these new verticals. Quickly to say, so kind of the history of this spotlight was quite straightforward. We started with the security spotlight back in Denver. Today was all about social on-chain. And just to announce, the next one will be in Bangkok, right? Whoa, cool, 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 cool. Cool. We have still some energy here in the room, eh? Awesome. So yeah, in Bangkok, so we are still redefining topics. We would love also for anybody that has a different point of view or different inputs on what we should really like debate and speak about in Bangkok. And yeah, feel free to share and enjoy the evening. We will have some of the DJ playing afterwards. And thanks for coming today. I think it was a great day. I hope everybody learned something more. And yeah, see you in Bangkok. And have a great evening.